Throughout the year, we learn mainly about irreversible reactions. These reactions include reactants which form a product. These are only one-way reactions and cannot be undone. Reversible reactions, on the other hand, can be undone and are two-way reactions. An irreversible reaction can be thought of as baking a cake, while a reversible reaction can be thought of as making a salad. Once the cake is made, you cannot pick apart the flour and eggs and other ingredients, but once you make a salad, you can separate it into its original ingredients. There are many different examples of irreversible reactions, such as hydrogen and oxygen forming water. There are also many different examples of reversible reactions. One is the evaporation and condensation of water. In reversible reactions, the reactants and the product are neither fully consumed, allowing for constant reaction and production. If you look at the basic irreversible equation, A plus B goes to C plus D, and change it into a reversible reaction, here's what occurs. The reaction A plus B produces C plus D occurs at the same time as the reaction C plus D produces A plus B. To picture this, you can imagine a dance hall with 10 boys and 10 girls as the reactants, and each pair of boy and girl become a product. If there are 5 pairs in the center and 5 boys and 5 girls on each side, and one pair in the middle breaks up and goes back to their side, like reactants, and forms another pair, making a product, and the cycle is restarted. This is the basis of reversible reactions. Unlike irreversible reactions, reversible reactions lead to equilibrium. In reversible reactions, the reaction proceeds in both directions, whereas in irreversible reactions, the reaction proceeds in only one direction. Equilibrium is reached when both of the reactions, A plus B produces C plus D, and C plus D produces A plus B, occur at the same rate. In irreversible reactions, the reactants may sometimes not be completely used, forming a limiting and excess reagent. The limiting reagent is the reactant that limits the production of the product, while the excess reagent is the reactant that is left over from the reaction. One popular example for describing limiting versus excess reagents is car manufacturing. If there are 16 bodies and 16 wheels, and one car needs one body and 14 wheels, then only 4 cars can be made. The limiting reagent is the wheels, and the excess reagent is the bodies. That is because when 4 cars are made, 4 of the bodies are used, and 16 of the wheels are used, because one car requires one body and 4 wheels. The limiting reactant, or reagent, is the one that is completely consumed, and the excess reagent, or reactant, as in the name, is the reactant that is left over in excess. In order to determine the limiting reactant, please look at the screen for viewing an example. First, the chemical equation must be balanced. Next, all of the elements must be converted into moles by using the molar mass conversion factor. After that, find the mole-to-mole ratio of the equation and use the amount of limiting reactant to calculate the amount of product produced. If necessary, do the same to find the excess reagent. The empirical formula is the simplest formula of a compound. The molecular formula can be the same as the empirical formula, or can be a multiple of it. The empirical formula can be found by following the steps of the song: percent to mass, mass to mole, divide by small, multiply to a whole. This means to take the percent composition and convert it into a mass, multiply it by the molar mass conversion factor, divide it by the smaller number, and multiply them until they are whole. To find the molecular formula, you must first find the empirical formula. Then you must find the molar mass of the empirical formula. You then have to take the given mass of the molecular formula and find out how many times the mass of the empirical formula goes into it. You then multiply that number by the whole numbers found in the empirical formula. See the screen for an example. Percent yield is very simple to calculate. It can be described as actual over theoretical yield times 100. The actual yield is found through an actual experiment or, in a classroom setting, may be given. Theoretical yield is the amount of product that could possibly be produced in a given reaction, calculated according to the starting amount of the limiting reagent. For an example, look at the screen. Relating to that, you can find the percent composition of compounds. This is very helpful in finding out the molecular formula. First, you find the molar mass of the compound, then you take the mass of the individual compound and divide it by the molar mass of the compound. View the screen for an example.
The year was 2005. This was the year that 3 friends were made. Hairy hydrogen was separated from a covalent bond with oxygen, known as H2O. Sunny sodium was separated from an ionic bond with chlorine, known as NaCl. Lastly, there was Larry Lithium. He was a special one. He was released from a salt bond with a halogen. Unfortunately, hydrogen could not exist by itself and had to form a diatonic bond. He was sometimes a laughingstock of the crowd, for you see, he did not have any neutrons. He was also ridiculed and called a simpleton because he was compared to Bohr's model. Harry was popular one of the group. He was like light. He was a particle. But when he ran, oh, what a wave he was.
All we did was rake a profit while disobeying the doctor. Heavy hydrogen, we killed 17 innocent ribosomes. Ribosomes murdered my family and my clan. Don't tell me about the lives of ribosomes.
Yeah, I'm with Harry. But how much time as lone molecules? Soon we'll need to form bonds for the big project.
Now can we talk about something real? Check out those valence electrons on Kira Krypton. That's what I want in an atom that I form a bond with.
I wouldn't mind forming hybridized orbitals with her, if you know what I'm saying.
Hey! We will all get no respect if we just sit here in detention for something we didn't even do.
Tell that to the families of the ribosomes we murdered, you insensitive fool!
Scene 2, 2 days earlier, the classroom.
Class, how about we learn about some balancing? So if I have 1 Larry Lithium on one side and 2 on the other side, what should I do?
Gee, maybe you let me sit down.
Are you talking back to me? You're getting detention.
Oh man, we were gonna watch Professor Einsteinium at the Atom University show us how to find out how many particles we are made of. It is 6.02 times 10 to the 23rd. I'm gonna get you detention because I don't care who I hurt on my way to the top. What are you doing? Teacher! Sunny sodium is licking my desk. No, no! Ah! I'm missing an electron! I'm missing an electron!
Are you sure? I'll call the noble gas nurses to help you. It will consume a lot of energy on their part, though.
Yeah, I'm positive. Ha! Got you there.
Sunny sodium, that's detention for you.
Man, I hate you.
Now let's party.
party, 17 ribosomes were slaughtered with scimitars. The students involved were given 2 months Saturday detention.
Welcome to Saturday Detention. I'm Instructor India. Okay, you guys are here because you thought you could get a kick out of slaughtering innocent ribosomes with your scimitars while high on vacuole juice. You are the worst atoms in the school, and you will never ever help society. The most you can ever become of yourself is maybe a weak acid or a weak base. Not even a strong base. You will not help with anything in your life. You will not dissolve in a reaction and bring in new molecules into this world, nor will you help to construct a new molecule. You are the lowest, least common, and most unstable isotopes in this world. And we need less of you. Now, you will sit in this room for the next 4 hours, and you'll write an essay on why you need to turn your life around. If you talk, you'll be expelled. If you don't write your essay, you'll be expelled. If your essay is subpar, I swear that your legs will be running at a higher frequency than gamma rays. So, take attendance. Sunny sodium, Larry lithium, Clarice chlorine, Brad bromine.
Here!
We're all here! Looks like everybody's here. I'll check back in later. You maggots better behave.
I can't believe I'm stuck in this place.
This is gonna be so boron. That's not funny, but I have a good one. Do you want to hear a joke about sodium? Or should I say you?
Nah. Chemical symbol for sodium. Also synonymous with the...
Who invited the mix of neon and RD? Or should I say nerd? Nice one, Harry. Such a nerd, Larry.
Huh.
And, by the way, we can't start our essays. The papers are gone. We need to get those papers. I have a strong hankering that this jerk teacher has taken them. Why do you do that? Your theory makes me about as uncertain as Heisenberg.
Because he wants us to fail, you frickin' Lewis.
Watch yourself, or you're gonna be missing an electron. Oh. Come on, fellas. We have to focus on getting those papers. It's very important to me that I write a very good essay.
You're right, Sonny. Sometimes we just forget about ourselves in this big, big world.
By the way, Larry, I like your outer electron shell. Is that Valentino Couture? So soft.
Your compliment was sufficient, Harry. Wait, is that where 2 electrons are connected by a mysterious action, and when one is altered at any location, the same thing will happen to the other?
Yes, it is. That is the jazz I'm looking for that will get us out of this sticky situation. But how will that help us, my friend?
You need to cool it with the anti-molecular remarks, chump, or there will be some real problems in this hood.
What are you going to do with your small radius? Just get out of my face before you take these mad metallic characteristics.
Now make me remove an electron.
I can remove an electron with E. The E in which you need. Oh, da da da! Da da da! Whoa, break it up, fellas! This is not the time! 15 minutes later, after the scuffle. It's okay, I'm sorry I got so hot-headed. It's just that my parents, Sally Sodium, and chlorine, having some issues. Is it okay, my friend?
Yeah.
I'm just glad we're all friends again. Let's have our seats. Is that a raincoat, Harry? Yes, it is.
What's your ploy?
Watch and learn. Observe how you spooky action to get back at our scoundrel instructor. Got the paper! Got the paper! Yeah! We resolved this problem like any other hydrogen molecule. Our friend Harry helped us out that day. We learned something. We came in as atoms, and we came out as molecules. Opposites can become close allies, just like metals and halogens can form the most powerful of salts. You just gotta remember to follow your dreams, and whatever you do, you gotta try your best, and you gotta try hard.
Chemistry. Oh, it's chemistry. Chemistry. Chemistry time. The class. Harry hydrogen. Larry lithium. We up in this compound. Mic check 1 2 1 2. Let's make this one count. We're bringing the bad boys back in the bunch. Like a 6-carbon chain, no one's late for lunch. But it's more of a brunch with these fresh scones and fresh beats. Similarly, they go crunch.
Opposites reacting, forming and compacting, but they ain't slacking. Chasing a full shell, a full dream with their team. They cannot be stopped like a train full of cops. I'm just skimming verses off the top. Oh! Chemistry, 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 chemistry time in the classroom. Ooh. These lines so sick they make Heisenberg certain. Just make sure Schrodinger's cat don't take a pee on your curtain. These fools look like they're hurting after hearing these rhymes. Like they drank water and lithium while reading the Times. Don't whine about what you think. Look at the facts. Take a minute while I count these fat sacks. Ooh.